So if you remember, we have several situations. Here's one situation possible, a nice one. Here's another situation. And here's another. This is a nice function. It's a one-to-one function. In other words, not only each x corresponds to one y, but also one y corresponds to each x, to one x. This one is not even a function. It's a relation, because I found one x value that corresponds to two y values. We don't care. What about this one? This one is not one-to-one. Why? Because each x corresponds to one y. Each x corresponds to one y. Each x corresponds to one y. But I found one y that corresponds to two different x values. It is a function, but it's not one-to-one. And what's the big deal with one-to-one functions? Well, it's a big deal. Why? Only one-to-one functions have functions. Anyone remembers this word? Only one-to-one functions have functions. Only one-to-one functions have inverse functions. Like here, I can create an inverse function from here, here. Here I cannot, because it will not be a function. If I look from this side, it will not be a function. This one I don't even need to talk about. Only one-to-one functions have inverse functions. And this is by the horizontal line test, not vertical line test, horizontal line test. So here is a function. This is a function. Is this one-to-one? No. By the horizontal line test, for one y value, I have multiple x values. Is this one-to-one? This is one of our best friends. Is this one-to-one? Is this one-to-one?
Yes.
Yes. By the horizontal line test, it is one-to-one. Yes, this is one-to-one. This one has an inverse. This one does not have an inverse. Okay. I want to give an example of two inverse functions. The notation is F inverse. Remember what I said? This is one function, and this is its inverse, not 1 over x. So here's the notation. Notation. F inverse. That's how we read it. F inverse, not f raised to -1 of x. This is F inverse. Like this is the inverse of this function. F inverse. Okay? So can anyone give us two functions that we know are inverses of each other? Simple functions.
Log and exponential?
Brilliant, brilliant.
Whatever.
Natural log x and e to the x. Excellent, excellent. If two functions are inverses of each other, what do you think, if you remember, the function composition in any direction will equal to? Here's an example. I give you $10 and then I take it back. What are you left with? You have X amount of dollars in your pocket. And I come to you and I say, look, let me give you $10. And 5 minutes later, I come back and say, give me back my $10. What are you left with?
X.
Exactly X. Not X squared, not X over 2, not X plus 3. This is the property of inverse functions. Natural log of e to the x is x. E to the x, e to natural log x is x. If I apply this function to this function, I get x. If I apply this function to this function, I get x, because they cancel their effect on each other. Whenever we graph the function and its inverse on the same coordinate system, we have to graph y equals x, not solid, dashed. If I want to graph a function and its inverse on the same coordinate system, like I'm going to graph the two that I really wanted you to say, I have to show that they are symmetric with respect to this line. What line? This. So if you fold the graph on this line, the red and some, I don't know exactly what shade this is, of purple, they have to overlap. If they don't overlap, they are not inverses of each other. So please always remember, when we graph the function and its inverse on the same coordinate system, we have to graph y equals x first. Okay. Any questions? There is a four-step procedure. Four-step procedure of finding F inverse. So let's look at any function. Let's say f of x equals negative 3x minus 4 over x minus 2. So this function is one-to-one. If it's not one-to-one, you cannot find an f inverse. But this is a one-to-one function. Rational functions are one-to-one. Okay. Maybe not all of them, but this one, the problem is telling us the function is one-to-one. The function f of x is one-to-one. Find the inverse. Okay. Here's the first step for finding inverse. Replace f of x by y. Is that possible? Yeah, they are always the same. F of x and y are the same. Number 2, interchange y and x. So the first step was y equals negative 3x minus 4 over x minus 2. In step 2, I interchange them. X equals negative 3y minus 4 over y minus 2. In step 3, solve for y. We've done this before, many times before. What do I do? How do I solve for y? First step, please.
You get rid of the denominator by multiplying the
Yes,
numerator.
it's a proportion. That's fine. That's perfect. Same thing, perfect. So I have y parentheses y minus 2 equals negative 3y minus 4. Next step, I'm solving for y. Next step would be anyone, please? We're solving for y. What would be the next step? How will you continue? We're stuck. Anyone, please help? Can we finish this one? How do we continue? What will be the next step? What will you do? Anyone, please?
Divide by x.
No? We're solving for y.
Add 4.
We're solving for y. 4 can patiently wait. Can anyone save us?
Divide by negative 3.
Can anyone save us?
Distribute.
Thank you. So we have xy minus 2x equals negative 3y minus 4. The terms with y have to be on one side. The terms without y have to be on the other. So we have xy plus 3y equals 2x minus 4. They are not like terms. Okay, what do? I still have to solve for y. How do we proceed if we cannot combine like terms, but we still have to solve for y? What should I do now?
Y parentheses x plus 3.
Brilliant. We are factoring out y. Finally,
Divide by x plus 3.
2x minus 4 over x plus 3. Step 4, replace y by f inverse of x. That's it, and it's done. So it's a 4-step procedure, a lot of work for this particular function. First step, we replace f of x by y. Step 2, interchange x with y. Step 3, solve for y. And we had several steps in that step alone. Number 4, replace y by f inverse. And this is the inverse function. Now, if the function, this is how mathematically we write, is defined on domain A, taking values in B. So this is defined. This is domain, and this is range. So if I have a function defined on domain A, taking values or having range B, can anyone give us what is the domain of f inverse? And what is the range of f inverse? Anyone remembers this?
The domain is the range of the original function
Brilliant,
known
of
from-
course, that's why they're inverses of each other. Excellent. F brings candy to Halloween, and F inverse takes Halloween back to candy. That's the definition of the inverse function. F takes, I don't know, a trip from point A to point B. The inverse goes back from point B to point A. They have to have, you know, to be inverses of each other, they have to have the domain of the F inverse is the range of F. And the same thing with our previous example, as we know. Domain here is all real numbers, range 0 to infinity. Domain here is 0 to infinity, range all real numbers. That has to happen. Okay, so what is left for Wednesday? So let me stop the video.